what is a prism? How do you draw a prism? A prism is a three-dimensional shape. A rectangular prism would look like that. A triangular prism would have a triangle as the base. Sometimes the description of a prism is that we have a shape on the bottom and then the height and the shape stays the same as we pull it up. So common ones are rectangular prisms, triangular prisms. When you get into round things, we give them special names, like a cylinder. A cylinder is when you have a circle on the bottom and it comes straight up. And so one of the things we're going to do in this unit is we're going to say, well, could I figure out the surface area of this prism? Could I figure out the surface area of this prism? If I painted this and then took all the sides apart, does this one make sense that it would have a rectangle here in the front that I'll put a check mark in green? And it would have that same rectangle on the back side. Okay? And then I would have a rectangle over here. Well, that is an awful check mark. But I have a rectangle here, and on the opposite side I would have the same one. And finally I have this rectangle on top, and on the bottom I would have the same one. So if we think about the shapes individually, we could figure out the surface area of this shape. The triangular prism would have 3 rectangles and 2 triangles. A pyramid. A pyramid is a shape that has a base. I mean, the pyramids that we think about when we think about in Egypt might have a square base or a rectangular base. And then they have some point where oh, this is going to be not the best drawing. It's not too bad. Everything attaches to that point. We're mainly going to deal with regular pyramids where this point that's up here is straight up from the middle of the base. Can you see that if you wanted to figure out the surface area of the pyramid, that if you looked at all the sides and the base, in this case the base is a square and the sides are each triangles? And if you look on your formula sheet, you see that you've got a lot of formulas. Formulas for surface area, formulas for volumes, and that's what we're going to be looking at in the second part of this unit. So we've talked about this already, a little bit of a review. If you're wanting to find the surface area for a rectangular prism, and we got a picture of one there, right? We're going to find all of the areas of its sides and then just add them together. How do you find the area of a rectangle? Do you remember this formula for area of a rectangle? That it's length times width? So then you could find one side, and then you could find all 6, and then just add them up. And like we said, sometimes there's some symmetry. In a rectangular prism, the front and the back side are symmetrical. If you get a cube is a special kind of rectangular prism, where all the sides are the same, where all the sides are squares, then you would have 6 sides that all have the same area. For a triangular prism, and that's where one side is a triangle and then you just continue that triangle all the way through. Again, you could figure out the 3 sides that are rectangles with your length times width formula, and your two sides that are triangles. And have you seen this formula before for a triangle? What does the B stand for? Base. H stands for height. So you take your base times height divided by 2. Sometimes it's written with a half out in front. 1/2 base times height. I'm not sure which one you're more familiar with, but they mean the same thing. Usually we do our base times height first and then divide it by 2. And finally, a cylinder, like I said, is like a special kind of prism where the base is a circle. With a cylinder, here I've got something like a cylinder right here. Or if you think of a soup can, does anyone have soup cans at home? Okay? What I want you to do tonight is go home to those soup cans, take the labels and take them off, and look at, yeah, your parents are going to be really happy, okay? And look at what shape it is when you take the label off. You ever taken a label off a soup can? It makes a rectangle, because you open it up and make a rectangle. If you're not sure if it does that on every can, take all the labels off. Every single can in your house, and then put them back. And then show your parents, look what I learned in math today. That the surface area around a cylinder makes a rectangle. So we can see with this cylinder here, if I take a piece of paper, and this actually works almost perfectly, and I wrap it around, it is almost perfectly around this cylinder. And sure enough, when I take that label off, we see that it's a rectangle. Now, something about this rectangle. First of all, can you see that the height of the rectangle is the height of your cylinder? But the length of the rectangle, how does that relate to what we have on our cylinder? It's the circumference. Now, if you have that visual in your head, that cylinder, that paper wrapped around the cylinder, that this length is the circumference, and you remember the circumference formula, C equals 2 pi r, then the area of that rectangle is the circumference 2 pi r times the height, and that's the side. The circle on the top, have you seen that formula before for area of a circle? Pi r squared. And so we'd have pi r squared on the top and a pi r squared on the bottom. And so our surface area would be adding up those two circles and that rectangle. And the formula itself for surface area of a cylinder, 2 pi r squared plus 2 pi rh, of all the formulas you've seen so far, I would say that has to rank as one of the most complicated looking. It's more complicated looking than base times height divided by 2. It's more complicated than circumference formula, which is just 2 pi r, and area formula, which is pi r squared. And if you try to memorize that formula, you're going to run into trouble because things are similar but different, that it's something that is hard to memorize directly. But if you understand where it comes from, if you can understand that, oh, it's just a circle on the top and a circle on the bottom, that means I have 2 pi r squareds, this part makes sense. And if you know that the wrapping around is just circumference times height, then this part makes sense. And all of a sudden you've got this formula memorized, or at least you have the idea memorized and you can figure it out every single time. I would say, I don't have this memorized that I just say it off right away, but every time someone says, what is the surface area of a cylinder, I think exactly this, a circle on the top, a circle on the bottom, and a rectangle around the side, and I write out the formula. And it makes sense to me. Now, it's on your formula sheet this year, but sometimes formulas are on a formula sheet one year, but not the next year. Think grade 10 is the last year that you get area of circle formula on your formula sheet. And then grade 11 and grade 12, they just say, we expect that you know that already. On your formula sheet, this is the last year that you get a squared plus b squared equals c squared. Okay? Maybe that's one you feel like, I already know that one. I didn't need that one anymore. And that's what math does. As we practice things over time, you start to just know them. So, we're going to calculate the area of the following prisms. This one has a height of 45, a length of 80, a width of 35. I am going to color code. Okay? Sometimes color coding really helps you see what you need to figure out. So, and on the smartboard, there is a crayon option. And if you're ever coloring on a smartboard, there is nothing more enjoyable. What color should we start with?
Green.
Green? There's nothing more enjoyable on a smartboard than coloring with a crayon. So watch. It's just like a crayon.
Wonders how logic ecology.
Isn't that amazing? If you imagine hard enough, you can actually smell the wax. And if you go hard more in some places, it gets like darker. It's just, I have to admit, sometimes in math class, I've gone to the internet and pulled up coloring pages, and we have colored in class with the crayon option. And if you try it, you just, I don't know, there's something about it. Something about those childhood memories, it just feels good. So there we go. I'm going to color the top in green. For that green section, it's a rectangle. Right? We know that the area of the green section will be length times width. What is the area of that green section? Well, the length is 80. And are you okay with the 35 here also being the 35 up there? So we're going to go 80 times 35. Someone have their calculator? 2800? Good. Let's color code something else. Let's go.
Red.
You want red?
Yeah.
Okay. Let's do that side right there. Ooh, it's pretty. So my red rectangle. The area. Length times width again, because it's a rectangle. Does it matter which one I choose as my length and which one I choose as my width?
Nope.
No, because multiplying doesn't matter the order. So when we write this out as length times width, I could choose 35 as my length and 45 as my width. Is this 1625? 1,575? Okay, perfect. And finally, you want yellow. But if I use yellow pen on here, do you know what's the problem with yellow pen?
Oh, pen? I thought pen.
Well, I'm going to color it in crayon, but you notice I've been doing this in green because it matches the green, this in red with it matches the red. If I start writing stuff in yellow, oh, it's going to hurt your eyes. So maybe yellow.
Blue. Do yellow. It's good color.
Blue?
Yellow.
Okay.
Got it.
Oh, I can't find my crayons. There we go. Blue. So we're going to do this side. Oh yeah. A little little bit over the edge there. Nice.
You're really passionate about it.
So now, see, did you learn that coloring? When did you learn the coloring technique with your pencil, crayons, or crayon? That you should keep the same angle. Do you remember learning that? Last year. Love it. Okay, the blue one. Area is length times width. For that blue one, it's going to be times 45, 3,600. And so we've color-coded it so we can really see it. And I would suggest sometimes in our notes, if you have different colored pens, you're going to find sometimes doing that in your notes helpful as well. Because when you look at it later, those colors are going to help you remember what we did. And they also make you see really easily that, oh, this red matched up with this side, this blue matches with this side, this green matches with that side. Now, figuring out the total surface area, my surface area equals, why am I writing it this way? Let me... Good morning.
Is it okay time for Phil Clement to come to the office for a brief moment?
Yeah.
Okay, thank you, sir.
Why did I write it that way? Yes. There's two sides of each. There's a top and a bottom. There's 6 sides in total. So I wrote it this way to show that I have 2 of the green side, 2 of the red side, 2 of the blue side. What's another way I could have written that might have been even shorter? Yes. Squaring it, we got to be careful. I know what you want to say, but if we square something that's like 2,800 times 2,800, and you just want to multiply it by 2, right? So we could also say I have 2, oh, that's not green, 2 of the 2,800 plus 2 of the 1,575 plus 2 of the 3,600. Mathematically, I didn't write the times sign with an X. Now, probably starting in grade 9, you started to get introduced. Why don't we use the times sign as much anymore?
Because the X.
Because, yeah, algebra, right? We get used to algebra, and algebra has X's, so that can sometimes cause confusion. Okay? So when there's a number outside of brackets, that implies multiplication. Okay? Sometimes if the brackets aren't there, have you seen the dot as another symbol for multiplication? Okay? 2 times. And that dot's in the middle because we don't want to get it confused with a decimal place. Yeah? Okay. And so we take out our calculator and do this entire, does someone already calculated for me to save time?
15,900.
15,950. And we're not done yet. Because we need to have units. So looking at our original picture, everything was in centimeters. So area is always measured in squares. Because area is covering something. Okay? I mean, if I actually draw a centimeter here on the board, I'm going to say that that's about a centimeter. And that is a straight line that would be super thin. If I drew it actually as thin as it should be, you couldn't see it. But a centimeter square is a square that's 1 centimeter by 1 centimeter by 1 centimeter, and it covers up a space. And that's what area is. And so, according to our answer, we would need 15,950 of those little squares to cover the whole thing. It would be a really annoying assignment if I said, to really understand this, here is a box that's 80 centimeters by 35 centimeters by 45 centimeters. Can you imagine how big that box is? 80 centimeters is about like this. 45 centimeters will be about like that. So we've got, and then 35 centimeters would be about like that. So now I've got this box like this, and I give you a pail of these little squares and a glue stick, and I say cover the whole thing and count how many you have in total. 15,950 of them. There would be a lot of them. Okay. I want to do more math, but I'll stick to what we're doing today. Here we have our cylinder. We want to find the surface area of our cylinder. Again, we know our surface area formula from our formula sheet, and we know the idea of the surface area formula, that the surface area has two circles plus one rectangle. And again, I'll color code this because I'll crayon and color a circle. Nice. There's the circle at the top. There's also a circle at the bottom. And then the rectangle, which would be like the label, we can actually I like that. Oh, so pretty. Does it actually, like, can you imagine feeling the ribs of that tin can? You know how they have those?
Yes, sir.
Yeah, you can smell the wax, feel the ribs. It's perfect. Okay. Yes. At home, I'll play with crayons. That's what, every night before bed. So our blue crayon part, which is our circle. Our area for a circle is pi r squared. It is not a bad idea when you're showing your work, if you're going to do a formula, to write out the formula. It takes like a second, 2 seconds to write out that formula. And then after it, we now go and plug things in. I want to find out the area. Pi is a number. Is pi equal to 3.14?
No.
Right? That's a little bit of a trick question, right? The fact that I used equal. 3.14 is approximately pi, but not equal to pi. Whew. Okay. I say something, and then I'm like, oh, I've got so much interesting math about that I want to tell you. We're going to try to stay focused today. Okay? The radius, that's what R stands for. In this case, the radius is from the center to the outside of the circle. So our radius would be 2. And this is the symbol for squared. So we were talking about the difference between multiplying by 2 and squaring something. Of course, this is a bad example because they're 2's. When we go to our calculator for this, what we want to make sure we are starting to do is use the pi button. So if you have a graphing calculator and it's new for you, the pi button is right above the divide, above this little hat button. That's where your pi button is. We don't want to be using 3.14 because then we're technically rounding early. For the most part, your answer will still be accurate enough for what you need to do. But when I go pi times 2 squared, And this x squared button does the squared right away. You can also use this exponent button to do the squared. We get 12.566. I'm going to keep that in my calculator. 566. That is the area of my green part. I mean my blue part. Take out my crayon, my highlighter, crayon. In green, right, if you took that paper off, it would make a rectangle. The area of a rectangle is length times width, and the length is our circumference, and the width is our height. And again, I'm doing extra here to help you realize and see where it comes from, but we already have that in the formula. The 2 pi RH is already in the formula. So when we write things in, 2 is a number, pi is a number, the radius is 2. And the same thing I did with the last question. Often in math, when you plug a number into an equation, you plug it in with brackets. So we'll put a 2 there, and for the height, we'll put in a 5. Why are the brackets there, and why are they helpful? Well, if I didn't put in brackets, no brackets. What's the problem with no brackets?
You're multiplying by 25.
It looks like 25, doesn't it? Okay. Sometimes you get away with it by putting a dot in there to say multiplication, but the brackets are better, especially when we get into situations where the value that you're inserting is a negative value. Then the brackets are really important that they're there. So I'm multiplying this out, 2 times pi times 2 times 5. Should be 62.8, but we'll check it out. 2 times pi times 2 times 5. 62.83. Okay? Now, I figured out each of the things separately, but this is a situation where if I wanted to figure out the surface area, my surface area is 2 pi r squareds, so I'm going to get 2 pi r squareds plus 2 pi rh. In other words, with the numbers that I have, and I'm going to show you a couple of things with your graphing calculator, especially for those of you that the graphing calculator is new. There's some nice things that this calculator can do. We'd have 2 of this plus 1 of, oh, and I forgot to write it down. Go back to my calculator. 62.83 plus 1 of that. So a couple of things with your calculator. If you figured them out separately like we did right now, we need 2 of this one and 1 of this one. Part of the problem with using these numbers right here is I've already rounded them when I wrote them on the board. Okay? But your calculator can allow you to use all the decimal places. So I wanted 2 times this one. Doot, doot, doot. Isn't that nice? Plus 1 of that one. 87.96. So since I'm rounding here in the end, 87.96, and did we have any units? Centimeters. Okay? Imagine how big this is. A 2 centimeter radius would be a circle about like that. A 5 centimeter height would be about like that. That's like maybe, I don't know, how many of you like to bake or cook at home? kind of imagining that looks like it's a little bit bigger than a tomato paste can. Tomato paste comes in a smaller can, not quite as big as a soup can. And if I again brought out the bucket of the little 1 centimeter squares, and I said you need to glue them on there to make them fit, you would need almost 88 of them. You'd have like a little sliver of one left over if you were really good at accurately gluing them on. Chances are that would be pretty hard to accurately glue them on really well, but that is what you would get. So one of the things I'm doing here, and I'd like you to do while you do questions, is visualize what it's actually like. How big is this thing that they're talking about? Is that realistic or not? Because getting those ideas of measurements in your head for what they actually mean really helps you understand the math that you're doing. The other thing I want to show you with your calculator is we have the formula in its entirety here. And eventually, well, even right away, you're going to find life is really easy on your calculator because we can just plug things in right here. So I'd have 2 times pi, r is 2 squared, plus 2 times pi, r is 2, h is 5. And the calculator is really nice for typing in all of this at once. So 2 times pi, bracket 2, bracket squared, plus 2 times pi, bracket 2, bracket 5. Wow, that is not a 5. And so what I've done on my calculator is write it identically to how I wrote it in my notes. And what do we notice? Boom, it gives us the exact same answer all at once. That is even nicer than what I was doing before by having to move up and collect an answer from before. It's nicer because if I just used the answers that I got from the different parts, I might have rounded early and then my final answer would be off a little bit. So doing it all at once is the best. But right now, I'm still trying to get you to see that, oh, there's 2 circles on the top and bottom, and there's 1 rectangle around the side. And that's where those parts of the area come from. And that's an important thing for understanding. Yes?
So we did the formula and plugged in all the numbers.
And got the right answer, that would be perfectly fine and full marks.
So even, even if you just put the formula with the numbers and then just...
And wrote out the final answer, perfectly fine.
Full marks.
Yeah. Now, okay. So the temptation is just to use the formula and, oh, Mr. JR is explaining stuff, so now I can daydream for a bit. The explanation is the important thing, because do you know what's going to happen later? Is we're going to take this cylinder and stick it on top of that, and then ask you for the surface area. And you did some of that last year, and we're doing that again. But then if you don't know that there's a circle on the bottom that gets taken off, then you're going to be in trouble, right? So understanding the parts are important, but also understanding that this is faster and more accurate, well, not more accurate, but has less chance of error is important too, because we like to do things fast, okay? I mean, I know it's kind of, if you learn faster techniques, you're done your math quicker and you don't get to do it as long, and that's sad, but maybe you can just do more math then. Okay, so that is a review. This year, we're going into cones and pyramids. So new shapes, new formulas, and some new definitions. We already know what surface area is. That's the area of all the faces. In other words, it's the area that gets painted when you dip an object completely into paint and pull it out. Whatever the paint is touching is the surface area. Sometimes we have another definition of area that we talked about, which is the lateral area, right? If the great Pharaoh of Egypt said, you know what, I'm tired of my pyramid being yellow, I want it to be painted blue. This would be a situation where you'd be like, we're going to just do the lateral area because we do not need to paint the base. The Pharaoh will never know, right? If the Pharaoh said, no, I want the base painted as well, I need a bunch of you to lift it up and someone to go underneath and paint it. I would not want to be the guy underneath while seeing the guys on the edge going like, oh, this is the heaviest pyramid, and you're right in the middle trying to paint it blue as fast as possible. So in that case, lateral area, which is just the surface area without the base, makes sense. So we'll have some questions that say, can you find the surface area, and can you find the lateral area? And so if we were finding the lateral area of this, we need to know that there's circles on top and bottom and a rectangle around the side. And then we have to make a decision. I could make the decision to do it separate, circle and rectangle, and just add those together. Or I can make the decision to do the whole formula and subtract a circle. See that both of those would work? If I wanted to find the lateral area of this, I could just do circle inside. Or I could do the whole thing and subtract the bottom. Most of the questions with pyramids that we will deal with are with right pyramids. A right pyramid has some sort of polygon, multi-sided shape on the bottom. And usually that polygon on the bottom that we'll be doing is a regular polygon, which means like a square or a hexagon or something like that, perfect.
You said that a pyramid has a base that is a polygon. Then what would be a pyramid without a base? How would that even apply?
Well, I could have, okay, not a polygon on the bottom. So okay, I still have a point up here. I still connect all of those points to the top. That would still be considered a pyramid, but with an irregular shape on the bottom. Okay? And then the height of the pyramid is the perpendicular distance from the center of the base to the top or the apex. Why is the center important? Because I could take this point, can you imagine me dragging it this way and it would still move around and then this would shift? You could still have shapes like that, but we're going to talk about that being height, being straight up from the center. Some of them have special names. If you have equilateral triangles all the way around, that shape is called a tetrahedron. I think I have one in here. See if I can find it. There we go. I have a dice that's a tetrahedron. So you can roll it. Oh, you got the pointy part up. Roll it again. Oh, pointy part up. I don't know how you roll it maybe you have to look underneath the bottom if it had a number on it. This one has like 3 different numbers on the different sides. I don't know what game this is from. I just know that if you accidentally sit on a tetrahedron, it does not feel very nice. Slant height, right there. This is a right square pyramid where the base is a square, and the next one, the base is a pentagon, so we call that a right pentagonal pyramid. Here we have a regular tetrahedron that has 4 congruent faces, meaning all 4 sides are identical. how would you figure out the surface area? First you need a crayon, right?
Wait.
Okay.
So you times 4.3 by 5, divide that by 2, and then multiply it by 4.
So you're figuring out this triangle. Oh, that looks like a Christmas tree. Nice. So here's our triangle, and you're saying the area of a triangle is base times height divided by 2. So we're going to get our area to be 5 times 4.3 divided by 2. Someone have their calculator handy? Is it 10.25? No? 10.5? 10.75?
10.75.
10.75. And now this will be
One side?
meters
Oh, squared.
squared. And that's one side. What will we have to figure out the whole surface area? Oh, I should have made this should be green, right? There we go. Okay. So our whole surface area, since there's 4 congruent sides, we could take 4 of these 10.75s. And our surface area, okay, someone double check my mental math. It's good? All right. 43 meters squared. So we have different units now. We have meters. Are you imagining the size of this thing? I can scroll up a little bit. That thing is huge. 5 meters. This is a meter stick. You have 5 of those. 4.3 of them up like this. And I bring it into class with my bucket of meters squareds. And you have to the glue sticking is what would take forever. Because a meter squared is this big by this big, right? So one of the things that students often make a mistake on is they say, I know there's 100 centimeters, ooh, this looks dangerous, doesn't it? There's 100 centimeters in a meter. So how many centimeters squared are there in a meter squared? And students will go, 100. But it's not the case, because if we think about how big, right? Here, I'll draw it on the, so. There's my basic meter squared, and there's my basic centimeter squared. 100 of those is not enough. The 100 would only fill one row. Does that make sense? If I start dragging my hair on. 2, oh my goodness, 3. This is why we don't do this in class all the way. If I kept going, the 100 would only fill one row. I would also need, if I started stacking them, it would take 100 of them to get to the top. How many are in total in the whole thing? 10,000. So for conversions with meter squared and centimeter squared, you would need 10,000 of those little squares to cover the whole thing. A right rectangular prism has a base dimensions 4 meters by 6 meters and a height of 8 meters. sketch this pyramid. So now we are going to be practicing our art math skills. How to draw things in 3 dimensions. First of all, you know how to draw a rectangle in 2 dimensions, right? How do you draw a rectangle if you imagine that rectangle in 2 dimensions being laid flat on a table? So we'll start with the base that's 4 meters by 6 meters. We choose one line. I'm going to choose my 6 meters to go there. And then laying that rectangle flat in 3 dimensions, can you imagine that still being a rectangle but laying flat on a table? Okay? So this is a little bit abstract because what's this angle in the corner? Actual angle and on a rectangle? 90 degrees. Do you know how you show a 90-degree angle?
A square.
A square. So we have to draw squares here, but they also don't look like squares, but again, we're imagining it flat. Is that good? And then the height is 8 meters. So where do I draw the height from? Well, I start at the center, and then I need to go up 8 meters. So now this is 6, just trying to imagine, does that look a little bit longer than 6? Yeah, that looks a little bit longer than 6. I'm going to make that my 8 meters. So now this is the apex, or top of my pyramid. When I connect the lines, connect to this one, I'm going to connect to this one, I'm going to connect to this one, wow, and this one, and maybe I'll just draw a dotted line. Why? Because we couldn't really see it. I'm actually really disappointed with my second last line. I'm going to see. That's better. There we go. I think the first time I didn't have my tongue sticking out while I was drawing it, then that little extra focus. So there's our pyramid. Not a bad, I'm fairly happy with how that looks. So now you see a technique to draw that picture, draw the base first. We use the idea that it's from the center to the top, and we can draw the rest of it. Now we need to find the entire surface area of this. Okay? Can you see that you have 2 different kinds of triangles? Color code them. I have this triangle here. On one side with a base of 4, and this triangle here with a base of 6. Can you see that you would have 2 green triangles and 2 blue triangles? Plus, for calculating the surface area, we're going to also need to
use red so that it is purple.
Like if I use red and I just outline that a little bit. Can you still see the blue, the green, and the red? Okay, good. So let's start with the red, the rectangle, because that is easiest. That area is length times width. So we're going to get 6 times 4, which will be 24. So if you were color coding things in your notes or on a test, maybe you just want to take your blue pen and make an outline of that triangle in blue. And take a black pen and make an outline of the other triangle in black. And then take the rectangle and make an outline in red to help you see the different parts. So for my blue triangle, okay, I have an issue. Why can't I go 6 times 8 divided by 2? Because you will want to do that.
Because that's not the slant height, it's just
Right.
the height.
The 8 is the height of the pyramid. But if I'm wanting to find the height of my blue triangle, here's my blue triangle. The base is 6. Everybody's good with that. But the height of this triangle goes from the base to the top. And on the pyramid, that's described as a slant height of that side. Whew. How do we find that slant height?
Back again here.
Okay, so I am going to draw it in 3 dimensions and then pull it out of the 3-dimensional shape into 2 dimensions on the side of the paper. This slant height, which I'm now drawing in black, connected to the height of the pyramid, and that's a 90-degree angle. If I pull that triangle out, turn it and draw it right here. Okay? I'm going to put 2 little dashes on this line to see that you realize that that's that line. 1 little dash on this line so that you recognize that that's that line. Can you see how I took that triangle, turned it, and now have it in 2 dimensions on my paper? Tell me all the dimensions you know of that triangle. You know this is 8 because that came from the height.
The base is 2.
And how do we know this is 2?
Because that's midway point of the 4.
Because it has to be right in the center, so it's the midway point of this 4. And so if I want to find this, x, I'm going to have to do a squared plus b squared equals c squared, which is x. 68 equals x squared, and x is equal to, go to my calculator, the square root of 68 is 8.2, approximately 8.24. And so now I can figure out the area of my triangle to be base times height, base times height, divided by 2. .74 approximately. And finally, we're going to have to do the same thing with our green triangle. On our green triangle, we need to find this slant height. I'm going to make a triangle in green here with a 90 degree there. That one is really easy to pull out and draw over here off to the side. This is going to be 8, and this length
3.
will be 3 because it's the middle from here to here of the 6. I already used x. In a question where you're introducing more than one variable, should you use a different letter? I'll use c this time, so we can do a squared plus b squared equals c squared. 8 squared plus 3 squared equals c squared. 64 plus 9. Square root of 73. 8.54. Base of this one is 4. That's a 0. $17.09. This question has a lot involved in it so far, and we haven't finished it yet. Because what are we been asked to find?
The area.
The surface area of the whole thing, right? So we still need to find the surface area. If we look back at our picture, if we look back at the entire thing, we figured out the area of the bottom. That's our 24. We figured out the area of the blue side. Can you see that you would have 2 blue sides? And we figured out the area of the green side. Can you see that you would have 2 of the green side? And I got 107.65. And every time I do my calculations, I try not to use a rounded value until the very end. So that meant I was collecting values from my calculator that were exact all the way along. Our units here are meters, so this would be meters squared. I'm going to zoom back, because I know it got a little bit small there, and scroll down to the bottom. No, that didn't work. Wow, this is screwed up. Oh well. I'll zoom with that instead. This is where we're going to end for today.